Okay, so imagine you're on the moon and you fire a rifle bullet straight up in the air. Would a rifle work on the moon with no oxygen? I want you to think about that. All right. So they fire it, it goes straight up, and if we shoot it straight up, it actually is going to reach a point where it stops and it comes back down, right? So here we've got actually potential energy plus kinetic, and then up here we have only potential, okay? So we're going to set this energy equal to that energy, okay? So our energy is going to be the opposite of G, mass of the moon, right? Mass of the bullet divided by this R here, right? Which is that's going to be the radius of the moon, right? Plus 1/2 mass of the bullet, V squared, right? That's going to equal minus G mass of the moon divided by, I'll call it R prime. We're solving for that radius, right? Which is going to be, it will be, I'll call this R prime, right? Okay. Now, notice it says what's the greatest height it reaches, right? That's going to be above the surface of the moon, and so we're going to have to, once we figure out the distance from the center, we'll have to subtract the radius of the moon, right? Okay, so let's see if we can do this. Oh, notice that the mass of the bullet, the 3.2 grams, this doesn't happen in the electrical ones, but in the gravity ones, the mass cancels out, which is cool. So this is gravitational mass. This is inertial mass. We think they're the same. Okay, so let's write this in. Opposite of G times 7.35 E22 divided by, and right when we fire it, we're at the surface of the moon. So 1.737 E6 plus 1/2 1,000 squared. Isn't that weird? That's weird. That equals the opposite of G times 7.35 divided by the R that we're solving for, right? I'll call that R prime. Okay. So what I'm going to do is I'm going to find this entire side there, and then I'm just going to go this times this divided by this entire side here because of math. Okay. So the opposite of 6.67, E minus 11 times 7.35, E 22 divided by 1.737, E6 plus 0.5 times 1,000 squared. Okay. So now I've got this side is equals this, right? So now I'm going to go this times this divided by this guy. So the opposite is 6.67, E minus 11 times 7.35, E22 divided by that answer. And I'm getting that R prime is 2110972.037. Let's see, 1, 2, 3, 4, 5, 6. Or 2.11097 times 10 to the 6th meters, but that's from the center, from the moon's. Okay, so that's not how high it goes. We have to subtract R. So 2110972 minus 1.737 times 10 to the 6th. So I'm going to go minus 1.737 because we want to know how far above the surface it is, right? So we got to subtract the radius of the moon. That makes these problems a little harder, right? So I'm getting that is 3.74 times 10 to the, let's see, 1, 2, 3, 4, 5, 10 to the 5th, of course, right? Couldn't be 10 to the 6th. Okay. All right. 3.74 times 10 to the fifth meters above the surface. All right.